Okay, so this is the the Precalculus test review. There isn't already a test review. I guess this is a little video of the test review, and I have a good chunk of problems, and these are the formulas, right? So it's probably good for, I think, the first half of the unit. So I'm just gonna leave them here. If you want to look, I think these are the only ones you should need. Should be it. But anyways, might reference them. So let's just start it though. So it says that we have a graph, and it's supposed to be an arithmetic sequence, and it's asking us to find an expression and use that same expression to find a of 17. So obviously the expression is written a of n is a of k plus, okay, a of n is just a of k plus common difference, and then we have n minus k. So what we can tell from here is that it goes from 6, you move over, it goes to 4, and then it goes to 2. So you're just kind of jumping by -2 each time. So that's our common difference. So we can just write that d is -2. And so then we just kind of plug it in. We just want the formula. So a of n is a of k. We can just pick any term. I'll pick 6 since it's a1, I guess. So that will be a1, so it'll just be 6 plus, or minus in this case, our common difference. And then n minus k is, it's our first term because it's x is 1, so it's just going to be 1 because 6 is our first term. So that's the equation, and it says it wants us to find a of 17. So a of 17, we just plug it in. So that's 6 minus 2, 16, 6 minus 32, which should just be, we write it right here. 6 minus 32 is what? -26. Okay, the next one. So it's a g of n. It's a geometric sequence with g1 and r2. g1 is 12 and r is 2. Find an expression, use the expression to find g of 4. Okay, so g of 1, so our g of n is, and then I guess we could reference our formulas. Because, like, yeah, I guess we'll just write it in this form. Right, so it's supposed to be g of n equals g of k, r, n minus k. So let me try it like that. So g of n is g of k, r, n minus k. So we have values. We have g of 1, which we can use here, and then that also goes here. And then we have r. So that should be it, honestly. G of n equals g of 1, which we're going to use 12, r, n minus 1. Sorry, r is 2, it already gave us. So that's our expression. And it's g of 4, so just plug that in. 4 minus 1 is 3. 12 times 2 to the power of 3 is 8. So g of 4 is, what is 12 times 8? That's 96. Okay, next one. Let it be a geometric sequence with this. Okay, so with geometric sequences, right, since they're geometric, we can't necessarily, what we can't necessarily do is find slope like we can for an arithmetic, because they change. They're not the same. They're not a stable slope. So what we do is we just plug in values, the values that we have, and we just isolate r to see our common difference. No, not common difference, or something different. It's r to find for r. So what we're going to do is, we should write g of n equals, like anyone, let's use g of 3, and then we have r, n minus 3. So let's plug in that value, but we also have what let's do g of 6, because this is the other value. So we have g of 6, that's what we're solving for, right? We're plugging into this one, though. It's g of 3, r, n minus 3. So we have g of 6, we have g of 3, so that will just give us r. And we have n, because n is 6, that's what we're solving for. So we just have 128 is g of 3, which is -2, r, and then n, we know that 128 is our 6th term, so that's why n is 6 minus 3. 128 equals -2. 6 minus 3 is is 3. So we just have that. You want to divide by -2 on both sides, and then we get that r to the third was 128. It's divided by 2, then that's -64, or r, I guess. You cube root both sides, r is -4. And it asks us to get just the expression. All right, so we have it. So we just have g of n. We can use any term. Let's use g of 3, which is -2, r, -4, and then n minus that term, which is, that's the third term, so it's n minus 3. And that's our expression. Okay, let's do this one. So this is an infinite geometric sequence. We just have to look at how it's like shaped. So it goes 9, and then 9, and then 9. So what we're essentially doing is we're doing that 0.999, repeating, is just 0.9 plus 0.09 plus 0.009, and that kind of repeats. So you're pretty much adding, it's 0.09. Sorry. You're multiplying each value by 1/100th or 1/10. Sorry, 1/10. So yeah. So this is essentially what you're doing to each value. So that's for a geometric sequence. Obviously, that's your r value is 1/10. So if we were to, this is our starting value, 0.9. So we already got it. We know that g of n is g of k r n minus 1, and we want to do it in this summation notation. So, but let's get these points first. So g of k is our first value, is going to be 0.9. R, we just know that it's just multiplying by 1/10 each time. So we just 1/10, and then we know that it's n minus 1 because 0.9 is our first value, and then we want the summation notation right here, and it's an infinite sequence, so it goes to infinite. But the way I like to think about it is, when you're starting off, where your end value is going to be is the one that gets you to your first term. So in this case, it's going to be 1, because 1/10, because if you plug in 1, it's just going to be 0, and 1/10 to the power of 0 is 1. 0.9 times 1 is 0.9. So that gets you to your first term. So that means it's going to be like this. So this is basically the this is the sequence, the summation equation, I guess, that we use to find it, and it asks us to prove it. So, and we know that the formula that we do for infinite geometric sequences, it's right here, right here, convergent infinite. So we do a1, 1 minus r. It's not hard. If r is less than 1, which it is. So a1, 1 minus r. So our a1 is 0.9. So 0.9, or let's do it in fractions. 0.9 is just 9/10. A1, and it's 1 minus 1/10. So 1 minus 1/10, is it r minus 1, or is it 1 minus r? How do I not know the equation? No, it's 1 minus r. I was right. Okay, so that simplifies just to 1 minus 1/10 is just 9/10. Because 1 is just 10/10. 10/10 minus 1/10 is 9/10. So 9/10. And on the top, it's still 9/10. Which is just a 1-to-1 ratio, just 1. There's 1 here. So it's just 1. And we just proved with our summation that it's 1. Okay, this one, it says, write an explicit formula for an. We have to see how it's moving. So that, you just basically subtracted. Let me get the key out, see if I don't make any errors. I don't think I did, but I might have. Let's see here. So we're in, okay, I found it. Okay, so what you're doing is you're subtracting, what is that, 8? Yeah, you're doing -8 and then another -8. So it's obviously arithmetic. So your first term is 32, and your common difference is -8 because we're moving by that. So we can just put a of n is a of k minus d, or plus d, n minus 1. Plug that in. That's just a of n is a of k, let's use 32. 32 minus 8. And then n, it's our first term, so minus 1. Okay, so this next one, it's supposed to be 195. 195, not whatever that is. So you go -5 to 95, that's 100, and then another 100. So it's another arithmetic. Your A1 is -5, your D is 100. Do it again, AN equals, A1 is -5, let's do it right here. D is 100, so plus 100. N minus -5, your first value. Boom, just like that. Okay, these ones, it's asking you what type, quadratic, none of these anyway, so let's just see how it's moving. So it's plus 3, plus 3, plus 3, plus 3. So it's constant intervals right here. -2, -2, -2, -2. So it's the same, it's moving by the same, so it's going to be linear. That's how a linear graph works. It's going to be linear. Okay, right here, see how it's moving. Let's get this out of the way first. So, +1, +1, +1, +1, +1, +3, +5, +7. So you see how it's moving? +2, +2, +2. So the second derivative is you're adding a constant value. If you were multiplying a constant value, it would be exponential. But since you're adding a constant value, it's quadratic. Okay, so it says immediately following. This looks like a, what, application? This looks like an application one. Okay, so immediately following the AP Precalculus exam, memes are created and shared online. The number of people that have seen the meme can be modeled using a geometric sequence, where 1 hour after the exam ends is 1 hour, is hour 1. So that's our first term. At hour 3, total of that people. Okay, so we can just do this as A3, 2,500 people, and 20 people by hour 6. So A6 is 20,000. So again, it's a geometric sequence, right? We know that we can't find a slope of that because it's geometric. That's not how it works. So what you want to do is you just want to put it in a standard form. So let's call this, we're doing people and time, so let's just do P of T. So P of T is, we need a value, right? So we can put in this equation, we have P of 3, so we can put P of 3, and then we're looking for R, which is the value you need, and then T or X or whatever variable minus the term, and this is our third term, so we're going to put 3. Now let's plug in the values. Now since we want to find R, we can't just leave that as P of T because we're going to have multiple variables that we have to find, and we can't really do that. So we're going to put something we do know. We do know A of 6 is that. So we have 20,000 is P of 3, or A of 3, sorry, this should be P, that should be P. We know that P of 3 is 2,500, so we can plug that in. R, and then T minus 3, well, T is this term right here. And we know that's our 6th term, so we can just plug 6 minus 3. Save space, we know 6 minus 3, that's just 3. So how we would do this is we can just divide both sides really quickly by 2,500. And that's going to simplify to 8 equals R to the 3rd, or just R is 2. So we find that, and it's asking how many people listening by hour 10. So now we have the original equation. We have P of T equals P of 3, which we'll use 2,500, times R, which we know is 2, and then T minus, that's our third term. So now asks hour 10. So t right here is going to be 10. So we're going to plug 10 in there and here. Let me just, well, I'm just going to use the space. So you just plug in the values. It's going to be 2500 to 10 minus 3. It's just 2500. 2 to the 7. And 2 to the 7 is, well, 2 to the 5, 32, 64, 128. So it's going to be 2500, 128, which equals 320,000 people. So 320,000 people saw it by hour 10. So it's asking you write limitation for the end behavior. So a little trick here. I think they might ask for concavity too. So I'm gonna add that either way. So there should be C. It's gonna be C along with the limit station. So a little thing with concavity is if a graph, we know that concave down is this, right? In an exponential graph, it's not gonna look just like that. It's gonna look more like this, where it's kind of like half of one. So a way to figure out if it's concave up, concave down, especially when you don't have maybe the full graph like this one, they just give you the equation. You want to see how it's moving. So right here, you see that it's increasing. Obviously, the values are getting higher, but it's increasing at a decreasing rate. Because look, it starts increasing a lot here, but then it starts going little by little by little. So we call that this graph is increasing at a decreasing rate. You see this? It's increasing at a decreasing rate. Those are not the same. Increasing, decreasing, they're not the same. So then we know that this is concave down. For example, if the graph were increasing at an increasing rate, for example, if the graph were increasing at an increasing rate would look something like, let's see here, increasing at an increasing rate. I think it would look, no. Well, it will be hard to draw like that, but let's say if it was decreasing at a decreasing rate, it would look like this. You see, it's decreasing, and it's getting slower the amount it's decreasing. So it's not going to be, it's going to be decreasing with the way it's moving. So, sorry, okay. Decreasing, it's decreasing, and it's getting slower. How much it's decreasing? So it's decreasing at a decreasing rate. See these terms? They line up, so it's concave up. If they don't line up, it's concave down. If they line up, it's concave up. Anyway, let's write the limit statement. So lim as x approaches infinity. Okay, so we know that it's just going towards 0. Boom. And as x approaches negative infinity, that way, it's just going to negative infinity. Let's do this one right here. So if it gives you an equation, my best bet is to just kind of plot it and plug in values for x. If x is 0, then it's just going to be 2 to the third of power 0 is 1. So it's just going to be 5. F of x is going to be 5. So when x is 0, y is 5. So it's going to be about right here. Say this is 5. So x is 1, then it's going to be 5 times 2 to the 3. So f of x will be 10 divided by 3, which is like 3 point something, I think. So it's going to be about right here. And keep doing this. Let's say x is 2. It's going to be 2, it's going to be 4 over 9. So 5 times 4 is 20 divided by 9. It's going to be a little less value than that. So it's going to be a little lower than that. So, and then let's even do 3. So 3, it's going to be 2 to 2 and 2. That's 8 over 27. 5 times 8 is 40. So it's going to be 40 over 27. And that's 40 divided by 27. It's 1.4888888. Right? So it's going to be a little less than that. You can say, eventually, this graph right here, what g of x is 5, 2 of 3 to the power of x. It's just going to, the asymptote is going to be like this line right here. So it's going to look like this. The asymptote's just going to be I guess, the x-axis. So it looks much easier to see now. We plugged in the values. So let's write it. And look, you see, okay, so what it's doing is it's decreasing. Obviously, the values are getting closer to 0. And it's doing it at a decreasing rate, right? They're getting the 0 slower, okay? The jumps are getting slower. So this is decreasing at a decreasing rate. So these two are the same, so it's going to be concave up. And you can kind of see that it looks like a boom. Okay, this limb as x approaches infinity, its value just gets 0 because that's the asymptote. And as x approaches negative infinity, well, it goes up to infinity. So it's that. So, and then increasing and concave down, which of the graph could be this? So look, it's increasing and concave down. Well, what do we know about this? We know that for a graph to be concave down, it has to be increasing at a decreasing rate. Because then look, these two would be different, so it would be concave down. So let's look at the ones that are increasing. Can we eliminate anything that are decreasing? This graph is just decreasing. That graph is decreasing too. So let's see which one here is at a decreasing rate. Well, look, this one is going like small, or this one's going small jumps, small jumps, small jumps, boom, big jump. So it's increasing at an increasing rate, which is concave up, and that's incorrect. This one right here, look, it's decreasing, but is doing it at a decreasing rate. Sorry, increasing at a decreasing rate, and that's the one we found here. So let's see. So which of the following statements is true about the exponential function given that by that? Okay, well, we can graph it. Remember, plug in the values. So when x is 0, it's just going to be -3, which is about right here. When x is 1, it's going to be -12, which is about right here. X is 2, it's going to be like -48, which is a big jump. It's going to be -48 right here. The graph looks like this. Now let's see what it says. Okay, it's always increasing. Well, it's not always increasing because you can just see here it's like decreasing, so that's wrong. Always increasing, wrong again. Always decreasing, and the graph is always concave up. Well, it's decreasing at an increasing rate. Decreasing at an increasing rate. Those are different, so it's concave down. So it can't be concave up. So decreasing the graph is always concave down. Yes, that's correct. So the function, which of the following is equivalent form for x? Well, we always want to get it to our lowest terms. So the possibilities could be 3x squared times 5 squared x, you see? And then we can just simplify that to be 3 squared times 5 to 2x. And it looks like we have 3 times 5 to the x over 2, which is not right. And then we have 3 times 5 to 2x, which looks something, but there should be a squared here, and it's not. So it looks like the only possibility is for this to remain a 9. 9 times 5 to the x, no. X divided by 2, nope. And it's d. Okay. Function is given by that. I don't know why I got cut. Wait, can I? There we go. Nope. So, this, if f of x is 10, what is value of x? Well, if f of x is 10, then it's going to be 10 equals 1,000 power of x. Now let's get this in terms of x or in terms of 10 to compare it. So we just have 10 to the 1 is, well, 1,000 is just 10 times 10 times 10, which is 10 to the 3. And you want to multiply it by the x right here. So it's going to be 10 to the 3x. So now they have the same base. They don't even matter anymore. Now it's just, the equation is 3x equals 1. And divide both sides by 3. So x is 1 over 3. And what is the value of x? Well, it's just 1 over 3. See, this one's, they want these to rid them of the horizontal transformations, which means just to kind of get x alone. So what do we know here? We know that that's just 3 squared, right, times 1 minus 2x. So let's simplify that as 2 minus 4x, okay? And obviously we're going to multiply all that by 1/4, but we'll take care of that later. So simplify that further, that's just 3 squared times 3 negative 4 over x. We can simplify this, look at that. That's just 9 times 3 negative 4 over x. And let's take the 9 outside with the 1 over 4. So we just have 9 over 4 times 3 to the negative 4x. But we're not done yet. We need to get it in terms of x. So, well, 3 to the negative 4 times x is just the same as, just same as 3 to the negative 4 times x. Boom. You see that to the power of x? So, and then we know that 3 to negative 4 is just 1 over 3 to the power of 4, and that's what? 3 times 27 times 4. Can't do math. Hold on. 27 times 4. Okay, 108. So it's just going to be 108. Sorry, 1 over 108. X 9 over 4. Which is easy. It's going to be 9 over 4 times 108 times x. That's our solution. Okay, this next one. So it's simple. We just break it up. 2 to the 5x times 2 to the 3. 2 to the 3, we can simplify that. That's just 8. And then we have just 8 times 2 to the 5x. And like we said again, 5 times x is just 8 times 2 to the 5 to the power of x, which is the same thing as 8 as 32 to the power of x. And that's our equation. Okay, so yeah, that appears to be it. That looks like it's the whole review. Don't know how long this will be, but look over test review, notes, homework, whatnot. I'm just going to leave this up right here. These might be good formulas for you to remember. And yeah, that's pretty much it. I think the video will end with a screen, or just pause it or whatever, screenshot it or something. Just remember these formulas. And yeah, that's it.